some of that information will come back to you. What we're starting today is looking at the normal curve. The normal curve models a lot of things in industry, in business, your grades. Not so much this class, because you're a college level class. I expect the grades to be higher, not more distributed. But maybe like SAT grades, and we've talked about that before, are follow a normal curve. Most of them are coming towards the middle, and the higher percentages are in the middle. And then you get a few real high ones, you get a few real low ones. Your curves are probably a little bit more skewed, and we've been looking at skewed curves. When we talk normal curves, everything has a certain way to it. And so we're going to take a look at that right now. But I want you to tell me first. We're going to define your properties of your normal curve, and it's on your note page. But I want you to tell me what you see in this curve. What stands out? Symmetry. Where is there symmetry? It looks like a big bump, right? Because it's like a mound. It's like a mound. So we see symmetry. Okay, what else do we see? Zero. Zero's in the middle. And what usually goes in the middle? What did we put in the middle before? The mean. And remember, I work at a slightly a little bit different than the book does. I want your standard deviations on the bottom, and I want all your x values on the top. What are these guys? Of what? Standard deviations. This is how far we are away from that mean. This is how far we vary off of that mean. Well, and we can be positive here, we can be negative. Our standard deviation is always measured in a positive number, but these are our z-scores. And when you were in Algebra 2, you had this all separated, and you had percentages in here. And we looked at your Algebra 2-1 in Chapter 2. And we looked at plus or minus 1. Does anybody remember what the percentage is for plus or minus 1 standard deviation? No? A little bigger. It's a big chunk of your curve. Look how big this is. 68%. 68% of your curve falls between plus or minus 1. How about plus or minus 2? Anybody remember that one?
95.
Good. And plus or minus 3?
99.7.
Ah, perfect. 99.7%. It's real close to the 100. And if you remember back, that when we graph this, if we technically graph this, look how little the percentages are here. Look how small this percentage is. So if you're going to graph this real tight, you're not going to fit anything in here. So remember we said we kind of exaggerate our curve a little bit, and we would make our 3s so that you could see them. They run real close, but we're going to have to exaggerate it a little bit because we need a little room to write in it. What do you also notice, and you can't really see it, but what do you notice about this piece right here? Where is it going? Is it crossing over this? It's on top. It's going to ride along this x-axis. Like an asymptote, exactly. Like an asymptote. So it's going to ride along this x-axis. Now, if you take a look at the properties that I gave you in your notes, we said the mean was here. Here's your properties. The first one, the mean is here. The mean, the median, the mode on a normal curve are all located right in the middle. So this is mean, median, mode. And the mean, all located smack in the middle. The normal curve is bell-shaped and symmetric. I said it was symmetric. So I have the same percentage to the left as I have to the right. What is the total area under this curve? The total percentage under this curve. How close were you getting over here? So what would the total percentage be? what's the total of all your probability outcomes for one event? 1. So the total area under this curve is going to be equal to 1, or 100% if I'm looking at percentages. It's got to cover 100% of my information. These little guys out here are so tiny, but they do exist. Okay, so the total area under your curve is 1, just like the probabilities. And when we work on your normal curve, we're going to tie them into probabilities, which is why we spent a lot of time on probabilities. The normal curve approaches this axis. We talked about this, and Sarah mentioned that it was like an asymptote, but it never touches it. It keeps going. We technically can find the z-score for 100. It would be ever so tiny percentages, but we can find it. And the one thing you probably don't recognize is an inflection point. We have 2 inflection points at the plus or minus 1 standard deviation. And what an inflection point says is this. As I'm on my merry way from left to right, I was kind of making an upward curve here. I was kind of going up, wasn't I? Well, then I changed my mind, and I decided instead to curve down. Then I changed my mind again and said, well, I think I'll curve back up again. Even though my curve's not technically coming up, I was an upward curve, then I turned down, then I came back up again. So an inflection point is the actual point where it actually turns. Did any of you take pre-calc? You took pre-calc? You took pre-calc. When we do this, you might recognize it better here. Here we're saying, okay, I'm coming along, I'm turning down. Oops, I changed my mind, I'm turning up. Oops, I changed my mind, I'm turning down. These guys are inflection points. On the normal curve, they set the inflection point at plus or minus 1 standard deviation, just so that we have some kind of a reference point, and we can work from there. So now, because our curve has symmetry, we're going to use that concept of symmetry when, just like we did at the end of chapter 2, when we see area to the right of 2, area to the left of negative 2. Won't they be the same? Because we have symmetry, right? So we'll be able to find this. We're going to also use the fact that half of this curve represents what percentage? 50%. So if I'm looking for a z-score, and we're going to find these guys, when I'm looking up here, and I want this whole thing, should it be more than 50% or less than 50%? More than 50%. If I'm looking to the right of it, will the right be more or less than 50%? If I'm here at my cutoff, and I'm looking to the right, this area to the right, if you look at your graph, is it more than 50% or less than 50%? Less. So we're going to keep that in mind too, because our graph is going to help us. So when we're working on these, I want sketches, just like we did when I was starting it at the end of chapter 2. Give me a sketch. Standard deviations go, your z-scores go on the bottom, your x values will go on the top. And we're going to work on the standard deviation part for a little while, and then we're going to apply these to applications, because that's when you start to see this actually work. Which curve has a greater mean out of these both curves? A. What is the mean for A?
Looks about 80.
The mean? About 15, right? About smack in the middle. Didn't we say the mean in the middle? Luckily, they all start with M's. Middle, mean, median, mode. This guy, what would you say this mean is for B?
It's hard to judge.
It's kind of hard to judge, but give me an estimate.
Say
10, 12, somewhere right in here, somewhere. Okay? What about the standard deviations? A has a larger mean. A has the greater mean. Who has the greater standard deviation? B. Why? Ah, good. It deviates further from the mean. It's more spread out. As it's more spread out, the standard deviation goes farther away from the mean. Good. So we said the spread of this affects the standard deviation. Good. Anything close together has a smaller standard deviation. Even though my mean is larger, it's less varied from the mean. That's very good. So take a look at these next two. Take a minute and tell me which curve has the largest mean.
How would be,
B. Why B?
oh, where's the right?
Furthest to the right. So my mean is in the middle. So my mean is going to be larger.
C has the greatest standard deviation.
So who has the greatest standard deviation? C, the larger of the standard deviations. C. Riley, who has the smaller standard deviation? A, it's the narrowest. These are the closest together. Less variation between the data. Closer together. Remember when we did the box and whisker? And some of your boxes were large like this and some were closer together, and we said that's how close the data was compared to being spread apart. Same kind of concept. Good. Okay. If we look at this, because we know that an inflection point is one standard deviation away from the mean, you can find the mean by finding the middle. The mean's going to be in the middle, and the one inflection point is going to be one standard deviation away. This is where I put my standard deviations down here, and I put my x values up here so that they don't get confused. And we're going to do that again together. Today we're just going to keep normal curve and standard normal curve. But when we do that, we're going to keep our standard deviations down here. So if you're looking at an inflection point, you can figure out approximately what a standard deviation is. That's a rule of thumb, just a rule of thumb. Do we really need to? No, but you can approximate. So if you approximate where the mean is, approximately at 675, you can take the difference between 675 and 710, and you can come out with 35. That would be your standard deviation. So that we'll take a look at soon too. Today, I want our focus today to be this curve, the standard normal curve. And remember we did your z-score values? We did the z-score back in Unit 2. We touched on this. This is where you're going to see this come back again. This is your standard z-score formula. And this is the only formula that you have to memorize, because this is the basis of this. Your standard normal curve is just like a normal distribution. The only thing is it has some special cases. It has a mean of 0, and it has a standard deviation of 1. So this allows us to find the area under your curve without using any applications. So the rest of the properties of your normal curve are going to apply. But the standard normal curve is going to have a couple of extra things. Now, when we make our curve, and take a look at your table. Pick up your table for me right now. Here's your table. Notice your table has a positive side and it has a negative side. Notice on the negative side, there's a little graph that's shaded. Where's the area shaded? To the left. Good. To the left. That means whenever we look up the area, we always find the area to the left. Next week, I'm going to show you how to find this on your calculator. But today, I want you to get used to the curve and the table. And the fact that these are symmetric, where are the positives and negatives? How can we estimate what our curve is going to be? So here's my 0, my 1, 2, 3. Here's my -1, my -2, my -3. Remember, our curve is a little exaggerated because we need a little space to write. Now, if you notice, what's the highest, actually the lowest point on this table? Look at your negative sign. What's the lowest value of the z-score? -3.4 what? 3.49. -3.49. The table only goes up to -3.49. Does our graph just stop at -3.49? No, it'll keep on going. But look how small those values are. See how small those values are? They'll get really small. They'll get smaller and smaller. because we're always looking at area to the left. So if I come out here and I'm at negative 8.2, my area to the left will almost be non-existent, but we can't say 0 because 0 means that can't happen. 0 means no area. It will be, but it will be little tiny. So if you watch your chart is building. Aren't the areas growing on this? Look at this chart for a second. I need you to understand how this works. So it starts really small. And by the time it gets up to the 0, 0, which we're going to flip to the other side, what's the area under the 0? What's the area for 0.0? Steven, what area do you have for 0.0? Look at your chart. Look at the bottom, the very last entry on the negative side. 0.0. 0.5. Why did I get 0.5 for 0 when the z-score is 0? It's half. It's half of your curve. Good. So doesn't that make sense to me? That this is 0.5? What is 0.5 in terms of percent? 50%. Isn't this 50% of my curve? Yeah. Now, turn it to the positive side. That's exactly where it starts. At the 0.0. At 50% of my curve. What happens to the area on this side? Is it increasing or decreasing, the areas? They're still increasing, right? Because area is to the left. So as I come over here and I get higher and higher, look, I'm more than 50% of my curve, right? So every time we do this, we're going to base this on, where's the halfway mark? Am I on the negatives? Am I on the positives? We're going to look for symmetry. We're going to look for everything to add up to 100%. Now, what's the highest number that this side goes up to? 3.49. So here's our special case, 3.49. And we're going to consider that the cumulative area, isn't it close to 1? Isn't it almost 1? It's 0.9998. Isn't it so close to 1? It's 100%, right? Almost 100%, but it's not exactly because we just found out that this curve goes on and on and on and on. Good? Okay. And again, we looked at increasing, decreasing, and we figured out at the 0, it's 50%. So this is our standard normal curve. Today, this is our focus today. Is to find out the z-scores, put them into probability statements, and figure out where do I find my area, to the left, to the right, to the middle. Okay? And we did touch on this in Unit 2, because I thought it was important when we did the probabilities that you understood area before we got there. Because they don't do this until after we do probabilities. So we did have some exposure, and we did look up our tables. So hopefully that will kind of come back to you. Now, I gave you an extra paper to do this with me. When we get to this part, we're going to do these together. This is important because I gave you to the left, to the right, and in between. These are your examples. Every year I start out going slow, and everybody's like, "It's so boring. Can we just move on? We got this." And every time I do this, somebody gets the negatives wrong, the positives wrong. Somebody forgets that it's 50%, not 50%. Somebody forgets where the symmetry is. So we're going to spend a little time working on this. Now, this one's not on here, but we're going to do yours in a second. So I want to do this one with you first. It says find the cumulative area. What does cumulative area mean?
Area added up.
All the area added up, everything that I've come to so far, for a z-score of 1.15. So where do I find a z-score of 1.15? But first, where would it be on my chart? To the right, kind of a little bit past the 1, right? This would kind of be 1.15. When I look up on my chart, estimate this. Before we look this up, estimate. What would the area be? An estimate. What do you think, John? Estimate. Give me a number. I'm looking up the area to the left.
You want to know what percentage that is?
Like, what do you think? Yeah, what percentage of that curve would you say?
I'd say
70.
75, I'd go up.
75. So why are you saying more than 50? Why are you giving me a high number? It's to the right, so I have at least half. Okay, so let's break this down just a little bit more. We said, and you don't have to do this, I just want you to get a feel for your curve. We said between, or you guys told me, between 1 and positive 1 and negative 1 is about 68% of your curve. Good? So therefore, between 0 and 1, what percentage of your curve is that? 34. It's half, right? Aren't these symmetric? 34%. 75 is a really close number because watch. If this is all 50 and up to 1, I'm 34%. How much is that so far? How much did I come from here to here so far up to the 1? 84%. So I'm pretty close with the 75, right? I want you to make an estimate. I want you to get a feel for this curve. Do you have to do this every time? No, but I want you to see the symmetry in this curve. I want you to see where positives and negatives are. I want you to understand this curve rather than just grab the table and look up the number and say, oh yeah, it says this. So now, let's look this up. So in your table, you're going to look up on your positive side. You're going to be on your positive side. You're going to take this and look this part right here, 1.1. And what do I do with that 5? Where do I find that? Good. Go along the top to 0.05. Come down here, and that's your area. So what do you find? What's the number that corresponds to that? What's the area? 8749. Look how close we were. We said it was about 84%. Look how close. You guys said 75. That was a great guess at that. That was a great estimate. Yeah, that was a very good estimate. That was a good chunk. That was 50 and a good chunk of your curve. Isn't most of your curve here? It's kind of like a sand castle thing. You have a whole bunch of sand. It's all laying flat, and you come by and you push it up like this. Where's the highest part going? In the center. Good. Right up here. This is where most of your data is sitting. Most of your data. And when we do applications, this will totally make a lot more sense. Because, for instance, for like SAT scores, the mean is in the middle. Most of your kids, 68%, are going to fall within one standard deviation of that mean. This is what colleges look for. They have cutoff points, and we're going to do cutoff points. And we're going to figure out where's the top 10%, where's the bottom 10%. Okay, traveling distances, tires. How far do tires go? Tires are said, well, if you get 5,000 miles, or 50,000 miles with this tire, give or take. Right? You bring it back and say, I went 45,000 miles. I'm so close. That's your standard deviation, give or take a little bit. So we're going to figure these out once we get to applications. Okay, so where would I find a z-score of negative 0.24? Between what two z-score values? This is a 0. Did I say negative 2.24? Sorry about that. Negative 0.24. Between 0 and negative 1. Closer to the 0 or closer to the 1? Closer to the 0. So I've got negative 0.24. And I'm looking for the area to the left. Give me a guesstimate. Yeah, give me a guess. When I look this up, what do I expect to find? Just a guess. A good guess from the curve. Say it again. 48%. I'm liking that. Why did you say 48%? Good. She's using the curve 50%. It's not exactly here. It's a little bit to that. She's saying 48, 49. So the price is right. So yes, let's see how close we come. So we're going to look this up. Look on your negative side. What am I looking up in the left-hand column? What number am I looking up? Negative what? So what am I finding on this side? negative 0.2, and what am I looking for at the top? 0.04. Everybody getting this part? Okay, come to where they meet. Be careful on the negative side, because you notice on the top, it goes backwards. What do you get for your area? 0.4052. So that's approximately what percent? About 40%, 41%. Very close, very close. But you use the fact that it's half the curve, a little less than half the curve, so we have a good estimate. You guys comfortable with looking at the tables? Okay, now we're going to go to finding our z-scores. All right, so you're going to grab your, you know how nice my board is. I need this board to last just a little longer. Okay. Pull up your sheet, because we're going to start doing these together. All right, the first time through, we're going to find the areas to the left. This is example 4, and try it 4. I want you to do this with me. We're going to find the area to the left of negative 0.99. Where do I find negative 0.99? Really, really close to negative 1, right? To the left or to the right of it? To the right of it. It didn't hit negative 1 yet. So negative 0.99. I'm looking for my area to the left. Give me an estimate. Chris.
Say like 33.
Okay, so how'd you come up with 33?
So, I don't know.
Okay.
Most of it's in the middle.
Uh-huh. All right, so it's less than 50.
So I was gonna say, from 0 to the right, that's already 50%. And if you add that part from 1 to negative 1 to 0, that's another 34%.
That's another 34.
So that puts you at about 84%.
The 84% that way.
Yeah.
Good.
And if you do 100 minus 84, that means less than.
So you're saying about 16%.
Yeah.
Okay, does everybody see what John's saying? And John's looking at it from the right side first, that's fine. He's saying this is a good 50% here. We just did the plus or minus 1, 34% here. So he's saying, oh, it's about 84%. This whole curve adds up to 100. That's one of your properties. So he subtracted it, and he's saying about 16%. And your guess, too, was around 30-something percent. 30-something percent is a good guess also, because it's less than half. I don't need you to guess exactly, but I need you to guess, estimate, because when you look it up, when we go to the right, and you say it's going to be less than 50, and it's not, then it's going to force you to say, oh, I got to subtract from 1. So keep doing your guesstimates. So now let's look this guy up. What do you get? 1611. 1611. Wow, look how close John was. Good job. Good job. Okay, so now, you guys try this next one. You guys try. Find where 2.13 goes. Shade in your area to the left, because we're still doing area to the left. Think about your guesstimate. I want you shading. You can use this curve, because it's the opposite side. You can use the same curve. I want you to get used to looking at these.
What if he wants to do to shade that part?
Well, you want area to the left. Right now, we're finding so you want to shade this.
Oh.
You're shading to the left. shading to the left. We want area to the left. How would I write this probability statement? I want to find the probability that the area, we're going to incorporate your probabilities into this. You told me that your total area for probability is equal to 1. So, to write a probability statement, I'm going to say this. What's the area to the left of this? Z is less than 2.13. Does this make sense to you? They're going to do this later, but I think it's probably a good idea to do it now. So, I'm looking for my area to the left. I want the area less than this. Right? So let's put our probabilities in here now, rather than later. If I shade to the left, to the left. No song, to the left. Am I the only one that has to you guys? That's how old I'm getting. That's how much time is changing. So where am I going to find 2.13? Close to the 2, right? A little to the right of it. Look at all this area that I want. To the left. I want my probability to say, what is my area? Area to the left of 2.13. So, guesstimate. Give me guesstimate first.
97.
97. 98. So when we look it up, what do you get?
I'm gonna say 47.
So I want you to really, really look it up. What do you get, Steven? 98.34. Did everybody get this? Everybody's good with that? I want area to the left. On your curve, I want you to shade your area to the left. Throw that probability statement in there too. That's probably going to help us later. So this is area to the left. All right, now we're going to change it up a little bit. We're going to look up area to the right. I know. They didn't want to work today because it's Friday, but oh well. Okay, find the area under the standard normal curve to the right of this. First, let's write this down. Let's make a probability statement. I want the area under my curve to the right of 1.06. Write this probability statement because this is going to help you figure it out. Which way is that arrow pointing? To the right. So I want the area to the right. So I'm going to look for 1.06, which is going to come real close to my 1. And I want to shade to the right. I want to shade to the right. So, guesstimate. Give me a guesstimate. You're like in about 85. Good. God bless you. How'd you get 85?
Was 84 from the rest of the last.
Oh, very good, Sarah. She's got 50 here, and she used the fact that we had 34 here. So she added a little bit more. Very good. Very good. You don't have to be exact. If you tell me over 50, under 50, so this is 84. So how much do you think it is to the right? About 16. I want the area to the right. So I'm looking at here, saying, oh, this, because when I look up in my chart, it's going to give me this. It's going to give me this big thing. So could this possibly be 84% when it's to the right? So I know this is to the left, 84%. I want to the right. So I'm using my 1 minus that. So it's about 16%. So let's see what happens when we look this up. So look up the number 1.06. Go to your positive side and look up the number 1.06. What do you get? 0.8554. Could that be the size of this area? No. That is exactly what Sarah said. It is the area to the left. So your rule is, when you go to the right, you want to subtract from 1. 1 minus whatever your table 4 says. So I'm going to subtract this from 1. Just put it in your calculator and subtract it from 1. If you can't find it on your table, but I'm going to show you another way to find it in a second. So subtract that from 1. Next week we'll figure out how to do it in your calculator, but we can also use the concept of symmetry. How can I want you to think a minute. How can I use the concept of symmetry to find that value, 1.446? I think hard. He's thinking. I want to automatically find that number, 1.446. How am I going to do that? Use the concept of symmetry. Sarah?
Put it to the other side.
Oh, if I put it where?
On the left of the -1.
So on the left of -1, so what would that value be?
0.94.
Uh,
Or -0.94.
if I'm going to use to the left, can I take this same thing? -0.106? You're so close. Is -0.106 and 1.106 the same distance from the middle?
Yes.
Yes. It's like my number line. Isn't it like an absolute value? What is the definition of absolute value?
Negative and positive is the same.
The negatives and the positives have the same distance from 0, because distance is always positive, right? So if this is the same away, and therefore when I look this up, isn't this going to be the exact same as this? Right? Using my concept of symmetry? Okay, so let's look up that. Let's look up -1.06. And tell me what you find. Oh, look at that. There it is. 0.1446.
On the dot.
On the dot. Oh, doesn't my chart have symmetry? Isn't it the same space to the left as it is to the right? Absolute value of a number, same distance away. Okay? Now, I want you guys to try this. -2.16. Where is -2.16, first of all? To the left of what number? -2. Be careful of your number line. But I want the area where? To the right. I want the area to the right. Make me a probability statement. Find me the area. Give me a probability statement too, because that's going to help you look at this. Shade. Make sure you shade. It's my area to the right. It's a big chunk of space, isn't it?
Yes.
I should expect a really large number. Okay with that? But I want area to the right. You're going to look like this. Look like you're going to shade this. It's hard because this is gray. I know. I couldn't get the gray out of this chart. It's not gray on mine, but it's pink gray when I see it. Then when you feel better. Try and find -2.6. That was over here. Put yours over here now. So -2.16 is way here. But you want to shade where? To the right. So anybody come up with an area for me? About 98. Sarah's saying approximately 98. So let's get the exact now. How do I get the exact? How do I find exactly?
Go to 2.16.
Oh, okay, so Sarah's going to go this way. She's going to go to the 2.16 because that's going to give me all my area to the left. She's using her concept of symmetry. So what do you get for 2.16, Sarah?
0.9846.
Oh, she's so close to the 98%. Okay. Keep these with you guys, and Monday, Tuesday, we'll finish this up. We'll come over this weekend so that you kind of get a good feel for where these go.